So you did the division, and what did you come out with, everybody?
X squared plus 2x.
Okay, so when you did the division, everybody, you did x squared plus 1. Stay standing, everybody. Stay standing. What is it? X to the 4th plus 2x cubed minus 7x squared plus 2x minus 8. When you did the division, what did you end up with on top? X squared plus 2x minus 8. If I asked you to factor the number 12, what does the number 12 factor into? 2 times 2 times... Not a trick question, everybody. 2 times 2 times? 12 is 2 times 2 times 3. That is the factored form of 12 because 2 times 2 times 3 is 12. Congratulations, it is the morning. So if I ask you for the factored form of this polynomial, I need to actually see what you multiplied together to get that polynomial. So you now know that x to the 4th plus 2x blah, 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 equals what? What does this thing equal? What does it equal? X plus 1 times x plus 4 times x minus 2. Yes, now you're done. That is the factored form. You've now fully factored it right there. Excellent, excellent. Now, why don't you factor x squared plus 1? Or why could you factor it? You can. But why don't we factor it? It's not a what? It's not a difference of squares, but we can still factor it. Everything is factorable, everybody. Just remember, it's not nicely factorable. Does anybody know what this factors into? It's x plus I times x minus I. have to use imaginary numbers. So what we're doing in this section is curve sketching, but we're going to start further back. I'm not just going to give you a sign diagram. We're going to have to find it. You're going to find zeros. You're going to find the intercepts. You're going to find where the derivative is 0, where the second derivative is positive and negative. So knowing how to factor is key. So do this one now. Same groups, everybody. Same idea. For B, factor that one. What's the difference here? What's the difference on this one? Synthetic division, did it work nicely? Yeah. If you didn't come out with 0 at the end, what does that mean? Either you did it wrong or it's not a factor. But theoretically, if I told you it's a factor, it should be a factor. Okay, sit down, everybody. So there was 2 ways to chip at these. There's 2 ways to chip at these. You either have synthetic division or what do you have? Yeah, you have polynomial long division. Nice, nice, nice. Okay, so let's move on here. Let's move on here then. So what are we going to do now? We're going to do something a little different here. We're going to do something a little different, which is put it all together. What's it asking you for? Intercepts, maximums, and minimum values. All points of inflection. Yep. Oh, sorry. Thank you. So make sure you do those individually. Do those individually. Okay, so this is what I'd like you to do. By yourself, find me intercepts, minimum and maximums, and the point of inflection. Don't graph anything. Don't graph anything. Find me those points first. Some of the intercepts? What are some of the intercepts here? We'll call that point. Section 1. Intercepts. Anybody got any? Intercepts.
-3, -2, and 2.
-3, 0. Those are x-intercepts you're talking about?
Yeah.
-3, 0. What else?
-2, 0.
Yep. And what else?
2, 0.
And 2, 0. Okay, there's one more intercept. What's the intercept that's missing? David?
Y-intercept.
Ah, then you need the y-intercept, which is going to be what?
-12.
0, -12. 0, -12. So you have the y-intercepts, and then you also have the x-intercepts. How many y-intercepts can you have at most? How many times can a function cross the y-axis? At most once. Does it have to? No, you could have an asymptote there. Okay, so there are your intercepts. What about maximum and minimums? Do you guys have that yet? Or are you still working on that? Still working on it? Okay, keep working on it. In order to find the maxes and min locations, everybody, what do you have to do first? What's the first thing you do? Find f prime. Can you tell me what f prime is, Natalie? What's y prime going to be?
3x squared plus 6x minus 4.
Minus 4. Exactly. Y prime. What?
Why'd you say y prime?
It's the exact same thing. Y prime is just another way of saying f prime of x. Because y equals f of x. Same thing. Same thing. Okay. Nice. Nice. So if you want to find where maxes and mins could occur, what do you set that equal to?
0.
You set that equal to 0. So you have 3x squared plus 6x minus 4 is equal to 0. And you hope that that's nicely factorable. Is it?
No.
No, it's not nicely factorable. So what do you have to do? Do the discriminant first. B squared minus 4ac. Again, do the discriminant first. Do the discriminant first. B squared minus 4ac. So you get 6 squared minus 4 times 3 times -4. So what do you get? 36 plus what?
48.
Plus 48?
Yeah.
16 times 48. So what do you get there? 80 what? 84. So what does x equal? -6 plus or minus what?
2.
The square root of what?
21.
The square root of, just say 84 all over 2 times 3, 6, yes. So you end up with negative 6 plus or minus, what is it? 2 times the square root. 21 all over 6. Right.
If you want us to simplify
So
that,
leave it like that's fine. You can simplify it. Don't obsess over it. If you left it like that, that's fine. As long as you state the answer properly. So those are the two x values where maxes or mins what could occur, right? They could occur. What do you then do next? What do you have to do next?
Enter them into your calculator using the plus and minus.
You could, but again, you could enter them into your calculator, but that's just for computational purposes.
You have to put it back into the original equation to find y values, right?
You could to find y values, so you know exactly. I like what you're saying. So the goal immediately is to find y values to see, so you get a points, right? Because x value is not a point. So if you did this out, you ended up with what? Negative 6 plus the square root of, I'll just say 84 over 6, comma something, right? And then the other one's going to be negative 6 minus the square root of 84 over what? 6, comma. Did anybody get values for those two? Yeah. Hold on. Let's get these values first, and then you can ask a question. The top one is what? What's the top one? Is type in each of these. Like type in negative 6 plus the square root of 84 over 6. Hit enter, right? And then hit STO, and then store it as like A. Store each of them. Yes?
To do that, like, is it alpha y equals to like quickly like do the y bars?
It's alpha on your calculator. I'm not quite sure what it's going to be. It's alpha could be happening at those values, at those points. It could be a min or a max, and it could be a min or a max. How do you figure out if one is a min or a max? How do you figure out if it's a min or a max?
Just like double prime.
Use the second derivative. Exactly. Find the second derivative. So if we want to find the we want to verify, this is still part 2. So first we find the what derivative? We find the second derivative. Can someone tell me what the second derivative is?
6 plus x.
6x plus what?
6. Yeah.
6x plus what? 6. And then how do you use the second derivative to tell if it's a min or a max? Yeah, Arvid.
You plug in the zeros of the derivative.
You plug in they're right there. What do you plug in?
the mins and maxes.
What are the points?
The x value.
The x values. Yeah, you take the x values, and what do you do with these two x values? You throw them into the second derivative, and if it's positive, that means you're smiling, so it's concave up, so it would be a minimum. And if it's negative, right? So let's just take a look at that. So you plug those in. If you plug in negative 13, like y double prime, negative 13.13, when you plug that in, is that going to be is that going to be less than 0 or greater than 0? Which one? You're plugging this number into this function. It's definitely going to be less than 0, like negative.
Yeah, that's the y value.
Oh, excuse me. You're absolutely correct. Thank you. You're plugging the x value in. So I don't actually have the decimal for that. I'm very sorry. What is it?
0.5.
0.528. And what's that x value?
Negative 2.5.
So if you plug in that positive one, so y double prime of 0.528, is that going to be positive or negative?
Positive.
It's going to be positive. And what about y double prime of, what is it, negative what? 2.528? What's that going to be? That's going to be negative. So if this is positive, it means it's concave up, and this is concave what? Down. So that.
I don't know if other people did this too, but I probably did like.
Well, hold on. Let's finish this phrase first, and then we can go to that. So what's this one going to be? A min or a max? The first one.
Min.
It's going to be a min because it's concave what? It's concave up. And what's the other one going to be? Concave down. So what do we now have? We now have intercepts. We have the maximum. We have minimums. And now we need to see if we can find a what? Point of inflection. Well, the point of inflection, you look at the second derivative. So that's the change in concavity. So when does this equal 0? So part 3 here. When does that equal 0? 6x plus 6 equals 0. When does that equal 0? When x is equal to what? Negative 1. So that's when x is equal to negative 1. We need the y coordinate. So where do we plug in negative 1? The original. The original. So if you plug in negative 1 into this, what do you get? What is f of negative 1 going to be?
Negative 6.
Negative 1, what? Plus 3 plus 4 minus 12. Is that correct? So it's going to, yeah, you're right, negative 6. So right here, could it be a point of inflection? Yep. Point of inflection. The way you verify that, because point of inflection definition is changing concavity. So you make that sign diagram, and then you have the x value as what? Negative 1, and then you have your second derivative. Remember it was, what was it? 6x plus 6. So when x is equal to negative 1, What was the second derivative? 0. What number is to the left of negative 1? What's easiest to... Negative 2. Plug in negative 2 into that. Is it negative or positive? Negative, 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 negative. Plug in something. What's to the right of 0? 0 or 1, right? It's going to be positive.
Is a point of inflection.
It is a point of it. We just verified it. So it's concave up here, and it's concave what? Down there. Yes, Alex.